With this background in mind, let me draw a timeline and let's see if you can make out of that timeline. This is the timeline, and at time 0 the swap value was 0. We are here at 30. So I'll say you are here sitting at 30 trying to find the value of the swap on 30th day. You know that after every quarter, that means at 90, 180, 270, and finally 360, at every quarter there will be an exchange of fixed with a floating payment. Now let's look from the fixed rate side first. The guy who is paying the fixed rate, what is happening to him? Now from the fixed rate side, the guy who is paying fixed rate, let's see what is happening. If I go back and try to see the values right here, he has to make a quarterly payment 6.052%. So right here, let me compute what happens with a 6.52%. A 6.052% annual is same as 6.052% 90 by 360 for a 90-day rate. So 90-day rate, I can compute it to be 0.015 kind of thing. So let's call it 0.015, right? This is 0.05 or 0.15, 1.05%. So this is not in percentage, so I can say this is around 1.5%. 1.5%. Now I look at what is the notional dollars there. So there was a notional principal of $30 million. So I need to multiply by $30 million. I will do that later. All I'll say, this is 0.015 per dollar. If I multiply by any notional principal, it will be the total amount for that notional principal. So this will be the quarterly payout per dollar. 1.5% means $0.015, right? For every $1 of the notional principal, this will be the payout at time 90. This has to happen. So I say $0.015. Then I say same will come out of 180, same number, okay. Then after 270, after 360. So same has to be paid because it's a fixed rate side. They are paying same $0.015, $0.015. Now I need to find the present value of these numbers, right? At time 30, I know after 30 these are the fixed. After 60 plus 30, sorry, after 90 plus 30, so 30 days have been passed. So 60 days later the first will come out, and 60 and 90, which is 150 days later, another coupon will come out. Can you see that? I'm sitting here, so I have to get the present value of all these coupons to this point, 30th day. So I know these coupons absolutely are coming at 90 day from 0th, 180th day from 0th. But since 30 days have been elapsed, I need to find out the remaining time. Remaining time is what I'll put in green now. So the remaining time is 60, since I am already sitting at 30. The remaining time for this is 150. Why 150? Because 90 plus 30 is 150. Remaining time for this coupon from here to here is a 240 day. Why 240? Because out of 270, 30 days has been elapsed. The remaining day here is 330 now, because out of 360, 30 days have already been elapsed. So my coupons remain fixed. I have to pay the same number here, here, and here, but my time period to compute present value has reduced by 30 days. It's no longer 90, it is 60. Not 180, it is 150. So let me compute the present value of the fixed coupon bond, where I know the coupon per dollar of notional principal is $0.015, and to compute the present value I must know the present value factors. The present value factors depends on what is the yield curve, LIBOR yield curve. It depends on LIBOR yield curve on the 30th day, right? So let's go back and see here. Now this is the LIBOR. Now this is the LIBOR rates at the 30th day. So after 30 days have passed, this is the new yield curve I could see. Can you see that, the new yield curve? LIBOR 60, 150, 240, 330. I have to use this rate to discount my fixed rate coupons. In other words, let me compute the present value factors for this one so that I can discount with them. So to go step by step, let me compute present value factors right here. So I say after 30 days have elapsed, let me put LIBOR here. The LIBOR 60 day, 150 day, 240 day and 330 day are given in the table. So what I am doing is just picking this table right here. So let me just pick this table from here. So I say this table which is given in the question, let me pick that table and let me paste that table here. So where can I paste it? So this is the table and let me extend that table. So let me remove this table right now. Now this table is not required. So in the original table, let me compute present value factors. So I say let me extend that table and say present value factors. How to compute a present value factor? The idea is simple. You say 1 divided by 1 plus this 6%. Now this 6% is annual, right? But I have to compute it for 60 days. So you say 60 divided by the full annual days, which is 360. So 1 by 1 plus r for a particular day. Similarly, I can compute 1 by 1 plus 6.5%. I have to compute it for 150 days. And similarly, the last one would look like 1 divided by 1 plus 7.5%, and it is for 330 days out of 360 days. The rates are annual, so I'm converting them. So get the present value factors for each one of them, and the present value factors that I get for 60, 150, 240 and 330 from a pre-computed set. In this case, the present value factors, if I put numbers here, I can say 0.99, it will be keep reducing 0.97, 0.95, and you can compute yourself to get the accurate numbers. Just putting numbers here, these are the present value factors. So I know the coupons from the fixed money that is returned. I know the present value factors for the days here, 60 day, 150, 240, 330. All I have to do is get the present value of all these numbers to get the value of the fixed coupon bond. Remember, the value of the swap is V fixed minus V floating. So I'm computing this right now. Keep the broader picture in mind. I'm computing this, the value of the fixed bond right now. So value of the fixed coupon bond per $1 of notional principal is defined as summation of the coupon into the present value factor of a particular period I, where I starts with a day 60th day, right? Whatever is the present value for a 60th day to I equal to 330 day. So that's the value of fixed coupon bond, and plus the final principal, right? That comes at 130th day. So present value factor of the 330th day. So principal, I am assuming it to be $1 notional principal. So that's the present value of all the fixed coupons that I will receive. I know the cash flow is $0.015. I know the present value factors from the last table. I know I need number, all of them with a different number because they are coming at different times. Present value factors, principal is $1 multiplied by the final present value factor, which is 0.93 right here. 0.9. So the last principal comes at 3/30th day. If I stand here, it comes here at 3/30th day. So I have to get the present value back to this time 30th.